So the description of the problem is below because you know what my handwriting is like. And yes, I'm absolutely working this problem with this jacket on. So nice little force problem for us. Read the description and try and work the problem ahead of time. But we have a 55 kilogram box. That's not even a box. We've got a 55 kilogram box. We are applying a 100 Newton force on it. And they told us that the coefficient of friction is 0.52. And we want to know what's the acceleration of the box, right? The coefficient of friction is 0.52. We've got a 55 kilogram box, and we've got 100 newtons for our mass. So we got some calculating to do and a free body diagram to make. So for my free body diagram, I've got my applied force here. I've got some sort of frictional force here that I don't know how much my frictional force is. I've got my weight down and my weight. I've got a 55 kilogram box. We're on Earth. So that is a 550 Newton box. And that means that the normal force, because we don't have anything else telling us different, our normal force, that response force is 550 Newtons also. So I kind of get my free body diagram, and then before I jump into the problem, I'm going to want to think, okay, so if I'm trying to solve for acceleration, I need to know what's the net force, because the net force divided by the mass is the acceleration. I know that's where I've got to get to eventually. I know the mass already is 55 kilograms, because they told me that in the problem, so I need my net force. What's the difference between my frictional force and my applied force? So my frictional force, I would just go to that frictional force equation, and that's mu times normal force. So 0.52 times a normal force of 5,000 or 550. So all I have to do is multiply those. So 550 times 0.52, and that means my frictional force is 286 newtons. So be careful before you just start slapping numbers together, though. That would go here, 286 newtons. Except that's more than my applied force. And friction isn't going to make something move. It keeps things from moving, right? So this isn't really my frictional force. This is my maximum frictional force. My frictional force in this case would actually be 100 newtons, because we haven't applied enough to overcome that friction, so we would have less than that, right? So we could keep pulling harder and harder and harder, and it would not move until I added 287 newtons, and then it would start moving. So the acceleration in this problem, since I don't have enough applied force to overcome my frictional force, my acceleration is 0, or my net force is 0, so my acceleration is 0. So we are not accelerating in this problem, right? Again, this frictional force that we calculate is the maximum amount of frictional force we could have. Since we only applied 100 newtons, our acceleration would be 0, right? We just wouldn't have enough there.